We're going to start looking at linear programming, and there's just two videos. You need to watch them both, and in fact, if you haven't already watched the videos on graphing inequalities and solving a system of linear inequalities, you need to watch those first, because I'm not going to spend a ton of time on those skills because we already worked on those in the other video. So here we're looking specifically at writing constraints and objective functions. So essentially what we're going to be looking at is a story problem. And in that story problem, they're going to tell us some information. And all of that information is either going to become a constraint, which is going to be an inequality based on what they tell us in the question, or it's going to be the objective function, which typically is one that we want to optimize. So we're either going to want to find the minimum of that or the maximum of that, depending on the situation. If we're talking about a cost, most of the time we want to minimize our cost. If we're talking about a profit, most of the time we want to maximize our profit. The values that we're going to plug into this objective function are called corner points. We're not going to look at corner points until the next video, and then we're not going to plug things into the objective function until the next video either. So this is a typical linear programming example. It's just a story problem. It gives us a ton of information. It's our job to organize that information to come up with the constraints in the objective function. So there are several constraints in just one objective function per question. Notice I've broken it down for you into 5 questions. That's just to help you get used to the kinds of constraints you should be writing. Typically I won't do that. So as I'm reading this question, I'm going to underline what will probably be a constraint, each one. So Jeremy has no more than 10 hours per week available for exercise. That's going to be a constraint. No more than 10 hours per week. Let X represent the number of hours he spends running, Y the number of hours he spends weightlifting. That's not an objective function or a constraint. That's just telling me use X for this, Y for this. Jeremy must spend at least twice as much time weightlifting as he does running. That is a constraint. Jeremy can burn 500 calories per hour running and 250 calories per hour weightlifting. This guy is a little bit different. This guy is actually going to turn into an objective function. And we'll talk about why as we're going through this. So the constraints is basically my attempt at constraining or limiting my variables X and Y. So the one a lot of people forget is A and B, or the ones a lot of people forget. And that's just that because this is a story problem and X represents hours spent running and Y represents hours weightlifting, those cannot be negative. So if running cannot be negative, then X must be greater than or equal to 0, because he could spend 0 hours running. Y would also have to be greater than or equal to 0 because he can't spend negative hours weightlifting. So again, that's 2 constraints that aren't specifically given in the question, but are things I still need to point out. They can't be negative. This guy is going to be what I labeled as number 1. The 2 combined hours for the 2 activities cannot exceed 10 hours. So running and weightlifting are both basically a workout, right? And so if the 2 activities, if you can't spend more than 10 hours a week, X plus Y has to be less than or equal to 10, because that's the total number of hours spent each. And then the one that I colored in blue says Jeremy must spend at least twice as much time weightlifting as he does running. So remember, twice weightlifting as he does running. Weightlifting is Y. So I'd have to take 2 times X, a lot of people get this one backwards, to be Y. And let's talk about the inequality in a second. Let's talk about why the 2 is on the X. If he spends twice as much time weightlifting, then I would have to take running times 2 to get to the amount of time he spent weightlifting. So a lot of people just say twice weightlifting, that's 2y and x, and that's not what we want. Now we're saying he must spend at least twice as much time weightlifting, which means he could spend more time weightlifting than running. So that's going to look like this. Or I can always flip that around. So weightlifting is greater than or equal to 2 times running. The last thing is the objective function. And the way that I specified that it's an objective function is that it doesn't really go with the rest of them. This one's talking about calories burned. And so obviously to write this, and typically an objective function we're going to write z and then x comma y because I've got two variables x and y. And then I'm going to say 500 calories per hour running would be 500 times x. And 250 weightlifting would be 250 times y. And notice I don't have that set equal to a number because what I'm going to end up doing is I'm going to either want to minimize that number based on my possible solutions, which we'll talk about in the next video, or maximize it. And typically we would think if we're talking about calculating calories burned, I'm going to want to maximize it. So again, our first example in the next video will be continuing this question. So keep this handy for when you watch the next video. We'll go ahead and graph, find the corner points, plug them in, etc. But right now we're just working on those two basic skills, the constraints and the objective function. Here's another one, and again we're going to complete this problem in the next video, but I would like for you to go ahead and press pause, see if you can answer all of these questions. Again, I've laid it out for you, so if you want to just cover up the bottom half of the screen and just see how you do without my prompts, that's fine. Otherwise, use my questions, make sure you get all the constraints and the objective function, then press play to see how you did. So again, we're dealing with an office manager needs to staff full-time employees, and this one doesn't say what's X and what's Y, so I'm going to make X full-time employees, and I'm going to make Y part-time employees. And it says full-time employees at $20 per hour, part-time employees at $15 per hour. She needs at least 20 employees, so that's going to be an objective function. Not more than 25 full-timers. That's going to be a constraint. They're both going to be constraints. The number of full-time employees must be greater than or equal to the number of part-time employees. That's also going to be a constraint. So what did I not circle? That's probably going to be my objective function. I'm going to be looking at full-time $20 per hour and part-time $15 per hour. That's going to go towards my objective function because that's going to be the cost of my labor, and therefore I'm probably going to want to minimize it. But we'll get there. So let's take a look at our constraints. Obviously, the number of full-time employees can't be negative. The number of part-time employees can't be negative. Don't forget those. Set up an inequality that shows the combined number of employees must be at least 20. So that's my first guy that I mentioned. At least 20. So combined together, at least, not at least 0, at least 20. Not more than 24 full-timers. So full-timers is X. So X has to be less than or equal to 24. And set up an inequality to reflect the number of full-time employees, which is X, must be greater than or equal to the number of part-time employees. So that's that. X is greater than or equal to Y. Or if you prefer to make it easier to graph later, Y is less than or equal to X. The objective function will have to do with how much I have to pay for all of this labor. So Z, X comma Y would be that I'm paying full-timers $20 per hour and part-timers $15 per hour. And again, am I going to want to minimize or maximize? I want to minimize how much I'm going to pay them. So again, stay tuned to the next video. We'll finish this question.